Hey everyone, and welcome to this explainer. Today, we're going to take the highly technical, sometimes intimidating OSI model and translate it into a simple, totally relatable story. We'll break the whole thing down in plain English, so by the end of our time together, you'll literally never forget how networks communicate. If you've ever felt completely overwhelmed by all the networking jargon out there, well, you're definitely in the right place. Let's get started. Okay, quick look at the agenda. First, we'll meet the OSI model, see how the office story begins, and then cover preparing the data, packaging and routing, physical delivery, and finally wrap up with why all of this actually matters. Section 1. Meet the OSI model, the framework of the Internet. So, what is it? Developed way back in 1984 by the International Organization for Standardization, this framework is basically the ultimate universal reference guide. It's the reason that entirely different computers, maybe built by totally different manufacturers on opposite sides of the planet, can actually understand each other and communicate seamlessly. Honestly, without it, the internet as we know it simply wouldn't exist. The model is sliced up into 7 distinct layers, going from top to bottom. You've got application, presentation, session, transport, network, data link, and physical. And hey, if you want an effortless way to remember these, just use this classic memory trick. All people seem to need data processing. Just take the first letter of each word. It's a lifesaver, and it's bailed out countless IT students during their exams. Now, here's the real kicker. Your starting point changes completely depending on your role. If you are the one sending an email, you start all the way at the top at the application layer, and your data works its way down. But if you're receiving that email, the data hits your machine at the bottom physical layer first and climbs its way back up. Keep this dynamic in the back of your mind because it's the secret sauce to understanding the whole shebang. Section 2. The office story begins. Sending a 400-page document. Let's ditch the dry tech terms for a minute and step into a corporate office. Imagine we're at the top application layer. Think of this as our company CEO. He just created a highly confidential 400-page document written entirely in French, and it needs to go urgently to a branch office in Delhi. This layer is just like the user interface where your data is born. Typing an email in Gmail or drafting a report in Microsoft Word. It's the actual software you interact with to create the data. Section 3. Preparing the data. Making sure it can be read. Because let's face it, just making the document isn't enough. I mean, a 400-page document in French isn't going to do much good for an English-speaking office in Delhi, right? Enter the presentation layer. This layer acts exactly like an office translator. Our translator takes those pages and converts them from French to English, so the receiving office can easily read them. In the tech world, this is all about data formatting. It's like slapping a .mp4 or .docx extension onto a file, so the receiving computer instantly knows whether to boot up a video player or a word processor. But wait, before we rush to send this incredibly important data out the door, we need to pause and ask a really crucial question. Is the receiving office actually open and ready to accept this highly confidential document today? And that is exactly where the session layer comes in. It makes that vital phone call. Picture the office coordinator calling up the Delhi branch to establish a connection and confirm, "Hey, are you guys open for business?" The session layer sets up, maintains, and eventually ends the connection. It makes sure the receiver is actually ready to accept the delivery before any data moves an inch. It's a total lifesaver for preventing lost time and dropped files. Section 4. Packaging and routing. Getting ready for the road. This is where our newly translated document gets boxed up for the big trip. So how do we handle this massive stack of paper? Well, at the transport layer, a worker divides the 400 pages into 4 distinct bundles of 100 pages each. Why? Because if you drop one box in transit, you don't lose the entire document. This perfectly illustrates the reliable TCP protocol, breaking data into smaller segments to ensure every piece arrives safely. On the flip side, if we just wanted pure speed and didn't care about losing a few pages, we'd use UDP. That's like tossing all 400 loose pages into a truck and hitting the gas. That's what your computer uses for real-time video streaming, where speed easily beats perfect accuracy. Next up, those bundles move to the network layer. Think of this layer as the company dispatcher. The dispatcher adds the logical to and from addresses, say from our office in Merritt over to Delhi. Then they pick the most efficient route, deciding that Highway NH58 is the best way to beat traffic today. Inside your computer, this layer acts as the router. It slaps on IP addresses and figures out the absolute best network path so the bundles reach the right city. Section 5. Physical delivery. Hitting the road. The document is translated, bundled, addressed, and routed. Now it's go time. Just before leaving the building, the bundles hit the data link layer. Our mailroom seals each of the 4 bundles into a secure envelope and slaps on a tamper-evident seal. The goal here? To detect any damage or interference during transit. The data link layer provides this exact kind of error detection on a network. If anyone or anything messes with the data on the journey, the receiver's going to know instantly because that digital seal will be broken. Finally, we hit rock bottom. In a good way. The physical layer. This is the actual, raw, physical transmission of the data. Looking at our timeline, at 0 hours, the driver loads the envelopes into a physical car. At 1 hour, they're physically driving down the asphalt of Highway NH58. By hour 2, they arrive in Delhi. In your network, this represents the actual copper cables, fiber optic lines, or wireless radio waves carrying those raw ones and zeros across the globe. And just like that, the sender's journey is complete. But let's take a second here. What exactly happens when that driver finally walks into the Delhi office holding those 4 sealed bundles? Well, the whole process just happens in reverse. The receiving office goes bottom to top. First, the driver physically hands over the boxes at the physical layer. Then, reception checks those tamper-evident seals at the data link layer. After that, the bundles are opened and meticulously reassembled into order at the transport layer. This flows all the way up the chain until a perfectly readable, fully assembled English document lands right on the boss's desk at the application layer. Section 6. Why this matters. Let's grab the core technical takeaway here. As our document travels down these layers, it physically transforms. We call this process encapsulation. It starts as raw data up top. At the transport layer, it gets chopped into segments. The network layer wraps those segments into packets by adding IP addresses. The data link layer shoves those packets into frames with those error-checking seals. And lastly, the physical layer converts it all into raw bits, just zeros and ones. If you memorize this exact transformation, you will instantly sound like a fluent networking pro. So think about this the next time your internet totally drops or a web page refuses to load. Can you spot which OSI layer failed? Is the physical cable unplugged at layer 1? Is your IP address routing messed up at layer 3? Or is your web browser just crashing at layer 7? The OSI model isn't just some boring textbook theory. It's literally the ultimate troubleshooting map used by IT professionals everywhere. And boom, the OSI model is completely demystified. You've now got a clear, solid grasp on exactly how data travels around the globe. Thank you so much for joining me for this explainer. But before we wrap up, I want to leave you with a thought. If this 7-layer model was designed way back in 1984 to standardize basic networks, what wild new layers are we going to need to invent for the AI and quantum networks of the future? Keep learning, keep troubleshooting. Also, please make sure to follow this channel for regular DevOps and cloud videos, and do subscribe to Zindagi Tales Hub. I'll catch you in the next one.